Continuing on to page 2, still finding the volume of the different images. So the volume here is still, now we have a pyramid. So I like to remember anything that comes to a point is just 1/3. And then area of the base times height. So I'm going to do 1/3 of it, or I'll do the volume, the area of the base times the height, and then I'll divide by 3 if you like to think of it that way. Okay, so for this problem, there's my 1/3. The base of this thing down here is this square. And it is a 20 by 20 square. So 20 times 20 gives me the area of the base. But the height, all right, the height of this is not 26. 26 is what we call the slant height. If you look at that red line is going from the peak of the pyramid down to the edge. I need to find the vertical height. So if I go right here from the center, what is that vertical height? So let me try to draw that in here. What is this vertical height right here? And this is a 90-degree angle as well. So I have this 90-degree angle coming from the very center of that pyramid straight up. So if I were to redraw that triangle, I'll kind of redraw it over here. Here is the height. This is the little 90-degree angle that you see. This is where it hits the edge of the pyramid. So this is like the side of the pyramid, which we know is 26. So if I want to know this bottom distance here, right, this little distance, I know this distance. It's right here, right? So this piece right here is this little segment right here. This segment goes halfway across the base. Well, I know that the base is a base of length 20. So since this has to go half of it, that is a base of 10. And now I'll do a squared plus b squared equals c squared. So I will do 10 squared plus h squared equals 26 squared. So once I find 26 squared, I'll subtract 10 squared, and then I'll square root it, and I'll find out, after doing all of this, h is actually 24. And there are no units on there, so it's 24 units tall. So that is my h, right? So you had to actually do some work to find the height. So then I can just type that right into my calculator. 20 times 20 times 24, and then divide by 2, and that comes out to be 3,200. And I don't know what the units are, so I'll just use the word units. And I know that they are cubed because it is a volume. So 3,200 cubic units. But you had to find h in that one, so that was what made that problem a little more difficult. All right, as I take a look at E, says answer in terms of pi. A cone has a circle, and anything that has a circle on it, you're always going to leave a pi there. So that's something to think about and get used to. So the cone, so the volume, again, it comes to a point, so I know it's 1/3 area of the base times height. I know that the base is a circle, which means it's pi r squared times height. Well, if the base is 4 feet across, then the radius is half of 4, which is 2. And the height has to be the vertical height from the center of the cone straight up, which it tells me is 5. So my volume is 1/3 pi 2 squared times the height of 5. So as I type this into my calculator, I will type everything in except for the pi. And when I do that, 2 squared is 4, and 4 times 5 is 20. All right, so 2 squared is 4, 4 times 5 is 20. 20 times 1/3 is 20/3 pi. All right, that is one answer you could get, 20/3 pi, or 20 pi over 3. But it did say that you could round any of your answers to a single decimal point. And if you were to take 20 divided by 3, I would accept 6.7 pi and my labels are feet cubed. So I accepted either answer, either 20 pi over 3 cubic feet or 6.7 cubic feet. All right, now finally to question 2. Question 2 says determine the volume of a ball. So a ball is a sphere. So volume is 4/3 pi r cubed. That's the volume for a sphere. It tells us it has a radius of 11. So the volume is 4/3 pi times 11 cubed. All right, same kind of thing, 11 cubed times 4/3. I'll round that to the nearest decimal point. That rounds to 1,774.7. And then pi. And my label here are millimeters. So millimeters cubed, or cubic millimeters. And that's it for page 2.